All right. Good morning, everyone. My name is Yuan. My name is Yuan Xie. I'm a professor in the ECE department. This is Santa Barbara. Today, I'm going to be the moderator for this AI panel. Okay. In this panel, we have 5 distinct panelists coming from different areas. For example, we have someone from IBM, big companies. We have CEO, co-founders from a startup company, and we also have researchers from research lab, okay, and including myself from academia. Okay. We look at what would be the interesting, exciting area, what other opportunities in this AI area. Let me start with the introduction for everyone. So this is my background. Okay. I'm actually working on. I used to be in IBM and AMD, working on hardware design, and now I went back to academia. My research focus still on the hardware solutions on AI applications. And then our first panelist, Savitha Srinivasan. Okay. She gave the keynote this morning. It was a wonderful keynote and presenting her vision in this area. And right now she's the VP of the IBM. And prior to that, she has been leading venture capital group in IBM and also worked for IBM Research. And she has many achievements, including like 30 patents and papers. And she also, I just realized that she actually continued to do some academic work, like serving as an editor for HP computers. And our second panelist is Chris, standing right over here. He co-founded a company, SkyMind and Deep Learning for J, the most popular deep learning framework for Java. And previously, he led the communication and coding for this Sequoia-backed Y Combinator stuff from Verizon, which was acquired by BlackRock last year. And interestingly, he spent more than 10 years as a reporter for New York Times and Business Week and Bloomberg News. And he attended Deep Springs College and also degree in commerce. Now the third panelist is Dr. Xinhua Lou. My student is sitting right there, right? He's the head of commercialization at a startup company called Vicarious. I don't know if the pronunciation is good. Okay. Yeah. He's a machine learning researcher and practitioner. He has published in many venues such as NIPS, ICML, CDPI, and MIT Press. And has won the Best Paper Award in machine learning for medical imaging. Okay. His current research, his current interest is to try to connect his company to the impact for real-world applications. Now, the fourth panelist, Dr. Zhou Hao, I think he's also here somewhere. Dr. Zhou Hao, yeah. Well, right now he's the CEO of Aboundy. His bio is in Chinese, so I will briefly mention a little bit about him. He received his bachelor degree from Tsinghua University, and then he went to Stanford. Within 3 years, he got 3 masters and 1 PhD. Okay, it's amazing achievement. Right? And now he has this interesting style company, so Aboundy. He said that he didn't send me any slide, but he wanted to keep it as a secret until we ask him questions. Okay, so we wait. Okay. And the last one is Dr. Chong Shi. Chong Shi, please stand up. He's a chief scientist in HP lab. He received his bachelor degree from Peking University and PhD from Penn State, and did a postdoc in UCAHP. Looking at his experience, you can guess there's some relationship between him and me, right? Yes, he was my former student. Okay. Yeah, so he will talk about a little bit about the AI hardware research. Okay. Now, the panel discussion, we will start with a short presentation for the introduction of each panelist's background. And then we will have a panel discussion with many questions. These are the sample questions, not necessarily the final questions. So you can just take a look. I may you may also have a similar questions. I think that I will open up the floor after the short presentation so that you have the opportunity to ask the question. So these are the questions that I asked the panelists to think about, prepare, but you may have some other more interesting questions to ask. Okay. So let me start with the presentation, short presentation. I think that the first one, this is your presentation, you already presented, but
yeah,
do you want to say something?
Make some comments.
Yeah, sure. Yeah, why don't you start first?
Why don't we go on, all of us to get together, or not?
You can do the presentation and then sit down over here.
So, hi everyone, thanks for joining again. Let me just make a couple of comments. I think the audience is highly technical, and I'm primarily, at least for the last 10 years, I've been primarily looking at commercialization. I want to talk to you. We have been following Vicarious very closely, and so in terms of commercialization. So we'll make more comments on that, but I just wanted to say maybe a couple of things on the technology framework, at least in terms of how IBM has been looking at this whole space called cognitive. I don't know if we can claim that IBM Watson came up with the name cognitive, but clearly you see a lot of that in the press. So I really just want to call it as, we have been looking at that really in terms of two broad technologies. Although you can argue the separation is artificial, right? However, you will see, if you look at all the press releases, our APIs, you will fundamentally see this dichotomy. We clearly see a difference between the techniques and approaches and the algorithms that we apply to structured data. And I was just chatting with you about that. So when you have numeric data, when you have time series data, when you have relational data, it's one class of technologies which is more traditional predictive analytics. That's how we see it. All the way from whether it's SAS or SPSS or R or whatever that class goes. There's both sets of technologies. That's what we've been sort of using on structured data. On the cognitive side, which is where a lot of the AI sort of buzz comes on, it's really the foundations NLP, right? I think that the base of it, you're going to find a rich class of sort of NLP technologies which give you access to the primitives that you need in natural language on which you build the semantics. So I think at least from IBM's point of view, the perspective would be, we've got these two big bodies of technologies and algorithms, and essentially under the Watson brand, what you'll see, and you'll see that illustrated in some of the solutions that we've brought to market, these technologies are brought together, right? And we combine them, whether it's for IoT, whether it's for the cognitive car experience. Just now at our World of Watson conference, we announced this major partnership with GM. And this is all about making your experience in your automobile that much more productive. And so the cognitive car experience, again, is a good illustration of an industry vertical solution that combines these two classes of technologies. So a lot more in the conversation. Thank you.
Okay, so next one's Chris. The slides.
Can everybody hear me? Hi. So my name is Chris Nicholson. I'm the CEO and co-founder of Skymind. Skymind is a deep learning company. We bring deep learning to enterprise, and we do so in an open source way. So you can think about us as the cloud era of deep learning. So big companies want to use AI. So Vika can tell you there's enormous interest in this field, but many of them don't have to do it. So they've got a series of hard problems to solve. They need the tooling, the talent, the infrastructure, and the data to make AI valuable to them. Skymind is a company that provides the tooling, and we advise them on the infrastructure, talent, and data. The clients, most large organizations have all the data they need. They're swimming in it. They just don't know how to extract value from it yet. So the tools we provide are centered around this open source library, Deep Learning for J. The J is for Java. Java is the largest programming language in the world. It happens to be the language of big data and the language of corporate IT. So we have built the most popular deep learning framework for Java, growing about 20% month on month in terms of our user base. What that means is we've added a very important layer to the corporate big data stack, right? A lot of companies already know how to gather, move, and store data. In the open source world and in the JVM world, they're doing it with tools like Hadoop, Spark, Kafka, Elasticsearch, Hive, Pig, HBase. These are all JVM tools. These are all Java tools. Now what we've done is build a powerful AI layer to go on top of that big data stack, right? And to give them very accurate predictions about the data they have. So Ethan mentioned a couple kinds of data the deep learning can work with. It can be unstructured media, blobs of pixels, blobs of text. It can also be structured, right? That's kind of the cutting edge is seeing what kind of performance gains we can get looking at log and web activity, transactions. So the use cases that clients bring to us, from finance, telecoms, and e-commerce, have to do with fraud detection, predictive analytics, such as predicting customer behavior, and image recognition, right? So you can recognize customers as they walk into your store. You can recognize persons of interest as they walk into an airport, right? You can recognize the goods they're holding and establish connections between those customers and their desires or affinities. So these are all use cases, the really low-hanging fruit, the old hard problems that companies have been trying hard to solve for a long time with traditional tools, where they can see a quantum leap in accuracy with deep learning. Because deep learning is the state of the art for an awful lot of products. So we have paying customers. They range from telecoms, tech companies, like IBM and Canonical, to LGE, and they are building real solutions with payoffs for their end users, right? So with France Telecom, it was reported in the Wall Street Journal, we're building fraud detection for them, right? With Canonical, we're building predictive hardware breakdowns. With LGE, we're helping them build smart appliances where the TV in your home can recognize who's talking to it and tailor its response to you based on that. Our product is called the Skyline Intelligence Layer, Skill. We've got Skill. And so the Skyline Intelligence Layer is that AI layer I was talking to you about. This is what it includes: deep learning for J, scientific computing, data pre-processing, and that's how it fits into the production stack. So as I said, you can see you gather data from a data source, you move it through a pipe, and you store it in a bucket. Right? Those are all the basic tasks, and then it feeds into an AI layer. And you could take this schema and you could apply it to any AI solution. That's the AI stack. Whether you use the Skyline Intelligence Layer or not, that's what an AI solution looks like in its basic form. That's a picture of what our GUI looks like. That's how we show people the resources they're using. One thing to know about AI is that it can be very computationally intensive, right? It means you rely on distributed computing. You're working on a cluster. You kind of have to know how many machines are available to you and what kind of work they're doing. So we work with tools like DCOS and Mesos to give people the information they need about that. Another way of thinking about it, because I said deep learning is computationally intensive, is that we are taking the JVM production stack and we're bridging the gap to academic hardware acceleration. Right? Academics have been working on deep learning for decades. They have learned how to use GPUs. The modern corporation has not yet learned how to fit GPUs into their production stack. We're helping them do so. So I'll just skip to, we wrote the book on deep learning. This is an O'Reilly book. The early release is out already. If you're curious about deep learning, you can go to Amazon or O'Reilly and see this book. This is my co-founder, Adam Gibson, and our head of field engineering, Josh Patterson. I think that's my 3 minutes. Thanks, Yuan.
It's good to be here, and hi, my name is Xing. I'm from Carriers AI. We are AI startup based in Union City, and we are quite unique, and we operate in ways similar to OpenAI and DeepMind. We're basically core AI research. So let's go through a bit about ourselves. Let's say it's 200 years back, we want to try to fly. We want to fly, and we draw inspiration from bird. And we have our technology such as mechanics, electronics. What's missing is our understanding of aerodynamics. And put them all together, taught us how to build our airplanes. So today, we want to build AI, and our studio, of course, is a human, and we have our technologies, like computers, modeling, robotics, algorithm, and so on and so forth. And what's missing is the one on the side of the human brain, so the brain sciences. And put those two together is what exactly I try to do, and is how we approach AGI. So to build AI, and we think we need to take neuroscience and cognitive science very seriously. We focus on data efficiency and task generality, and we want to leverage the state-of-the-art computing and modeling technology. So put all this together, we are building a lot of things. One of them is so-called recursive protocol network. It has a lot of unique features we build in, and we draw inspiration from neuroscience. And in recent years, we've been at the end of last year, and we've been publishing a lot of papers. There's a few papers where there's a few more coming recently. In one of the papers, we can see our performance. We outperform neural network or deep learning on a published benchmark of text recognition. And what's more important is that we use only 6,000 less amount of data to achieve this task. To put it in perspective, this big circle is the amount of data you need to train a neural network to do the same task, and the little dot is the data we need to do the same task. That's the uniqueness of our technology. And in the future, coming next, we try to build whatever we have into a real robotic body to do a lot of tasks such as assembly objects, such as picking and pack in warehouses. This will be our next commercialization goal. And that's about my case. Thank you.
The next panelist is Dr. Zhou, but he told me that his company is still small. So he would rather to skip the presentation, just go directly to the panel. In case you have any interesting question to ask him, if he can answer, okay. So he will tell you. So the next. So the next one, the last one is about hardware. So basically, I asked Chong to present it, but he said I am the advisor. He prefer me to present it, so I will present it on behalf of him, even though he's doing a lot of dirty work. So why don't you sit down over here? So I just want to let you know, example, we have heard about the application and also the business and startups things. One thing I do want to say is that the reason that AI application becomes so hot is one of the big reasons is because the hardware becomes powerful, making the hardware association for AI application becomes feasible, right? So our group in UC Santa Barbara is actually focusing on the AI hardware association. So our focus is looking at different hardware solutions, looking at how it can help the AI applications. Okay. For example, we look at heterogeneous computing, GPU, ASIC, and FPGA solutions, and also this new memory device, how we can actually enable much faster AI application in the future. Okay. So, like I said, okay, one of the key important applications for the AI is the deep learning, like what Chris also mentioned earlier. So in our lab, we actually looking at different kind of solutions. For example, like looking at CPU, GPU, and FPGA implementation for this AI algorithm. Okay. Another interesting thing is more research-oriented, which is looking at the future AI hardware application. For example, if you look at today's neural network and deep learning association, you can see that the hardware, even though it's good enough, it's very good right now, but it's not good enough. In the future, if you want to have much more advanced AI applications, for example, the bandwidth of the hardware could be a big bottleneck. Okay. If you look at today's computing architecture, basically it follows this what we call the Neumann architecture. Okay. You have a computing unit, you have a memory unit, okay, and then the data is actually moving from the memory to the computing unit to the computing and send it back to the memory. That's the traditional computer architecture today. But when you think about brain, there's no distinction between the computing and the storage. They're actually combined together, right? So we are actually looking at the future of the hardware for this AI application. looking at how do we build a brain-like computer. Okay, so one of the first steps we are actually looking at is actually recently we are looking at this compute in memory or processing in memory architecture. It's like there's no distinction between the CPU and memory. Everything is within the memory. Okay, so this is actually a first step towards the future brain-like computer. Okay, even though it's an initial step, but I think it's a promising direction. Okay. So that's all I want to share quickly to go over some of the hardware progress in terms of the acceleration for AI applications. Now let's get to the interesting part, the most exciting part of the panel discussion. Okay. So here I have some of the questions for the panelists. Okay. And I would like to start with all the panelists. So you can see that for all the panelists we have the microphone in front of them. Okay, these are sample questions that I wanted to ask them. But I would like to open up, instead of for me to ask them the question, I would like to let the audience to start the discussion first. Anyone want to ask questions to any of the panelists? 另外，我觉得在这里很多人都是中国人，所以我们也可以用中文，没有问题。If they ask you questions in Chinese, I will translate it for you. Yeah.
It's okay. 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 I'd like to ask a general question. So, like, what's the true essentials of intelligence? So people are talking about intelligence for many years, or 1,000 years, but there are no clear definition of intelligence. So I don't know, someone can give me your opinion, it's okay, but it's quite general. Like, what is the intuition? What's the thinking? What's the reasoning? What's the knowledge in general?
That's a complicated question. You know, the AI that we're making succeed now is narrow types of AI, right? So that intelligence is narrow. It's not general like your intelligence, like human intelligence. It's usually good at one thing, right? So the algorithms that we're training, such as neural nets or vicarious algorithms, right? They'll learn how to perform one task really well. They'll learn how to equal or surpass expert human performance, right? Recognizing images. But obviously, there's more to intelligence and there's more to being human in recognizing images, right? So goal-oriented behavior, achieving one's ends, that's crucial to intelligence. And the ability to master language and communicate, right? And we're not, and AI is not yet capable. Sorry, AI is not yet capable of doing that in highly complex situations. It can beat board games, but it can't really conduct conversations yet, or learn how to live a human life. Yeah.
Sure. I just wanted to know that's a great response there, Chris. But I wanted to share something. I mean, this is, I think, goes outside the scope of the panel. But here's one way we've been thinking about this whole notion of intelligence, right? And I think it goes beyond the technology, as you say. First up, today's AI, I agree with you completely. They solve narrow, specific problems, and in fact, you'll see it, widely. I think you would agree. We really think of it as augmenting human intelligence, right? Humans are definitely in the workflow associated with the process. We're not, handing off processes to computers and saying, "You go make the decisions." But take a look at another plane by which we think of how humans and AI-powered solutions are forming partnerships within the world. So traditionally, humans are, we excel at common sense. This is the cheat list I'm looking at, and it's elementary, nevertheless, right? So things like common sense, morals, imagination, compassion, abstraction, generalization, right? These concepts, I'm going to just assert that I would, associate them and attribute those to human intelligence. These are kind of, a subset, at least, typical qualities you would attribute to humans. AI-powered systems in parallel or as a complement, really, it's really about locating knowledge. Huge bodies of information is there. How do I locate just the precise information I want? How do I pattern detection, pattern identification, age-old AI problem. Natural language processing, again, well understood, well-known problem. Machine learning techniques, eliminating biases. I think that's a very good characteristic of AI systems and machines, and providing sort of, quote-unquote, endless capacity, if you will. So I think the way we would see it is really, here's a class of sort of attributes that are unique to human, and I would associate those with intelligence. And here's another set of attributes that are computers and AI-powered systems are particularly good at. And ultimately, it's really a partnership that's going to yield the best outcomes.
We think intelligence is the ability of acquired intelligence as intelligence. There's so many ways. For example, when a little baby was born, the baby doesn't have an idea of self. It doesn't know it has a body, has a leg and arms can move. So our baby try to move. The scientists try to acquire this knowledge by moving, by trying. So in addition to a lot of like common sense and morality stuff, and another big part of intelligence is the ability to interact with the environment, to identify yourself, to identify what's your relation with the environment, including the physical environment, including the emotional with other people, the relationships. So it's a very huge concept.
So I think this is a very philosophical question. It's almost equivalent to like asking who am I? So because I don't know, as an intelligent being, like what my life purpose is, well, maybe everybody think about. But from my perspective, like thinking about computers and human beings, the difference is like from a computational perspective, like as a number of computational power like goes up each year. Currently, like pretty within like decades, the number from deep learning networks, the neurons will exceed the number of neurons like human brains have, and also the big difference between computers and humans are like computers now, learning from unstructured data is still very difficult, and most of the problem is like the number of sensors for a computer is very like. I mean, it's very customized. Like, for example, if you are playing chess, probably you don't need a visual sensor, you don't need like an audio sensor. But humans, we have like we can touch, we can feel, we can see, we can hear. So there's like many multitudes of sensors of the human, and also you have a very lengthy learning perspective. As a baby was born, it's like a pre-configured maybe neural network, but throughout the years when you grow up, you learn from your parents, you learn from your colleagues, and also there are feedback loops. And also if we are thinking as like probably 100-year project, if like artificial intelligence can like achieve like a human-like capability, I think maybe that's possible. I was in an investment firm, like a trading firm, and when you play like when you make trades in the stock market, sometimes you have to understand like the sentiment. It's like a more like approximation, like the fear indexes. So computers, like I think in a narrow sense, they can learn fear. They can learn many like kind of emotions which if we make the definitions on humans. And I think in the future, maybe there's one day when we add enough sensors, we can make a computer as powerful, at least first computationally, and then second in terms of like the learning trajectory, and all the sensory functions, as close to human as possible.
I think all the panelists has covered the question pretty well, so it's time to move to the next question.
Sure. Do we have next questions? All right. Sure.
Yeah, AI has been around for many years as a branch of computer science. I'm wondering, at a high level, what drives this phase, this round of innovation and investments into it?
Yeah. What's the reason why AI becomes so hot again, right? Let me clarify. Okay.
Yeah, sure. So besides kind of the general answer that is applicable for all technologies, which is with the availability of compute power and easy access to sort of technology resources to leverage to build your next class of solutions. I think the fundamental reason that's really driving this investment is data, the availability of data. This is the data network effects that I alluded to in my keynote. So CEO Janito Mehdi says data is a new currency, and today it's a new natural resources, right? So, for example, the value of what you can harness, what you can unlock in terms of business value, whether it's revenue generational activities, or it's cost saving, or productivity, it's just unparalleled to anything that's possible today. Because today's platforms, whether they are enterprise platforms or consumer platforms, are just in this virtuous cycle of, sort of attract more users, drive more usage, collect more data, make the system more intelligent. So the data that is generated as a result of these large-scale usage, it makes a prime time for AI. So that's one perspective.
I mentioned the 4 things necessary to build an AI solution: talent, tooling, data, and infrastructure. And in fact, we see advances in most of those criteria, right? So infrastructure would be hardware, just to mention. Hardware acceleration, and as Yuan said, hardware acceleration is the precondition of progress in AI. They go hand in hand, right? The more powerful our hardware is, the more complex the models are that we can build, and therefore they can solve more complex problems until as they kind of get closer to human intelligence. So that's infrastructure, right? Data. Since the 90s and the advent of the internet, we have begun to collect more and more data. We are in the era of big data, and although some algorithms like Vicarious can train on very small data, most algorithms improve as you train them on more and more data over time. So now that we are inundated with data, we are able to train algorithms to the point where they can get very smart, recognizing data and making predictions about it, right? The tooling, right? The tooling is really the algorithms in a way, and significant advances in the algorithms have been happening since at least the 90s, right? And it was really in around 2006 with a guy named Jeff Hinton, who works at Google, that we saw the kind of latest big bang in deep learning, right? Where we saw what we could do. And since then, deep learning has just set a lot of new records in the accuracy that we can achieve on various data sets. And all that together, and the investments that businesses are making, is attracting an enormous amount of talent, right? Some of the best minds in the world are studying machine learning, they're studying AI, they're gravitating to the field, right? So we have this talent, we have better algorithms, we have the hardware to support it, right? Which wasn't there in the 80s, even though neural nets were known then, right? And we have the big data to train the algorithms on. All those things right now are here, right? The preconditions are met, and that's why we're seeing enormous advances almost every month in AI, right? And those advances, which start out in the research labs, are being applied to business problems.
Very complete answer, Chris. Thank you.
I can come from an academic perspective. So a lot of AI you see today was actually called to different names such as machine learning, data mining, statistical analysis. So among all those techniques, one highlight is the deep learning, which beat a lot of the important benchmarks that people cannot credit for. That gives people hope. People try to see that there's a possibility of a new sort of a new technology that can change the field that people cannot done by using, for example, feature engineering plus classified. That gives a lot of hope, and it has been expanded from vision to speech recognition to natural language understanding and so on and so forth. And it also gives the opportunity for Vicarious to try to build more advanced, different type of technology, try to be more efficient in data, more efficient in training. So overall, it's a great thing.
Yeah, I think it's mostly driven by the advances in technology that currently from computer vision or natural language processing. Those in some of the fields deep learning algorithms and computers are approaching or exceeding the performance of humans and starting to disrupting jobs or industries that thought are very labor intensive. So those industries are really huge, and the perception and also the trajectory of making them more efficient is what from the end user perspective driving the increasing investment in like hardware, software, and also research.
Okay, so I'm gonna answer the question from the hardware perspective. So if you ask this question to like Young Kun or engineer in the big conferences, usually hear a standard answer. So it's driven by the evolution of algorithm plus big data plus computing power. So if you look at the hardware perspective, you're seeing the GPUs getting more and more powerful today. And I'm going to give you a quick example how we actually use the GPUs in our servers in HP Enterprise. So basically, for example, we heard a lot of complaint from our business unit that if you use open source deep learning framework on the CPU for inference, basically for example speech recognition or image classification, actually the effective flops you can get out of box using the open source framework is less than 10%. So we took a little deep into the reasons behind why you get so low utilization of the flops. We figured out, okay, first the implementation of these open source frameworks are not highly optimized for a lot of Intel processors or AMD processors. And we realized, okay, for many of the processors, actually we have integrated GPUs there sitting there for free. So we asked why not use them? So that's why we actually started to think about how we actually effectively utilize this integrated GPU that's already sitting on your server for free. And by doing good engineering or open source implementation, we can actually get a pretty good, more than 15% of the flops out of the integrated GPUs that's already sitting on your servers. So you can start to run your inference service in a really short period of time. And if you look at the future, what I think is that ASIC FPGA on the way to make a success. And also the emerging technology that my advisor mentioned, that if you think about this emerging technology including 3D memory, 3D coarse point fabricated by Intel, and some other in-memory computing concept that enabled by this computing, by these technologies, I do see a really promising future in the hardware, from the hardware perspective.
Okay, more questions? This one, yeah.
I work in a telecommunication company, and we are looking into the domain of machine learning and deep learning gradually. So the question is, in the last few years, I think all focus are in the deep learning domain, as RLC is. But what about the non-deep learning, like traditional logistic regression, clustering? Is there any room for any advantage for this non-deep learning? And if so, what are the user cases which you think are deep learning and non-deep learning machine learning?
Let me classify and clarify. So far, majority of this AI opportunity focusing on deep learning. I mean, besides deep learning, there are many other machine learning algorithms or applications. What do you think are the opportunities besides deep learning?
I can talk about some of the main differences between deep learning and traditional machine learning algorithms. There are use cases for traditional ML. One of the main differences is that outside of deep learning, you have to do something called feature engineering. Right? Now, feature engineering is the selection of the variables that matter, right, to get to an accurate outcome. That selection requires domain expertise. It requires human experts to go in and tell the algorithm, look for X and Y and Z. Now, those domain experts are rare, which means that's a choke point for you if you want to build those traditional machine learning algorithms for a given use case. Now, deep learning automatically extracts features, right? That's one of the magic things about it. It automatically extracts features and defines which things are important if you just give it the data. Where it's difficult is in tuning the hyperparameters, right? Deep learning requires a type of tuning, right? That in itself requires expertise and knowledge. So the necessary skills are shifting from feature engineering over to hyperparameter tuning. But if you can bridge that gap and get over to hyperparameter tuning, you will probably get greater accuracy, right? And a greater accuracy can mean hundreds of millions of dollars for large companies. Now, there are trade-offs. One of the trade-offs is that traditional machine learning algorithms like random forests are highly interpretable. They have explanatory power, right? They can come back to you and say, here's why I decided that this transaction was fraud. Here's why I decided that face was Savita's face and not Chris's, right? With deep learning, interpretability is still something we're working on. Right? We're getting better at it, but we're not as good as the algorithms that have been told by humans how to make their decisions, right? So if you're in a highly regulated environment, deciding who to give a loan to, for example, where you have a government agency waiting for an explanation about your decisions, you may want to use an algorithm with greater explanatory power.
I'll just add a comment to that, right? So I think, while I agree completely that you need the domain expertise to determine what features are relevant to a particular problem, I think that whole process has become so much more democratized today. I'll give you an example. So, Cit Science is an e-commerce fraud company. They've been following them for a while. And it's kind of like your Google Predictive Analytics API. It's good. So the training set that you give, so you're a unique merchant, you're XYZ, the characteristics of the people that you want to flag for fraud have these unique characteristics, only you know about them. Because you're from this geography, you're users of this kind. But in less than 10 calls to the API, you tell it, here are the features, you give it, here are some positive, training set, positive examples, negative examples, highlighting what the feature is that it needs to trigger on, and you're done. So I think, although you need the domain knowledge to know about the features, I think that process is not as challenging in a lot of different domains, particularly e-commerce. So I spent a lot of time tracking machine learning companies in commerce to see what's relevant to IBM's business. And I would say that process is relatively made quite palatable and quite easy for people to incorporate.
I think that the answer to your question is yes. For example, Vicarious is exactly doing a different approach. We try to use polyspectral models to model the human brain from many aspects, and starting with the perception. So there are different application scenarios. So deep learning is very, very useful if you have sufficient data, if you can acquire data, and if you can control the quality of the data. Otherwise, it's just garbage in, garbage out. If you can do that and you have enough GPUs, deep learning will be very useful, very powerful. And you can control your future, your test, and your test time, you can control the input. That is very, very useful. For us, we focus on technology that we train them on clean data and high quality data, but we only need a very, very little of them. And we can be better in generalizing to whatever change in the scenario, change in lighting, or change in the color, whatever things. That's our strengths.
From certain industry perspective, especially financial industry, deep learning hasn't been the main focus of the industry yet. Especially so far, deep learning has been very successful, but mostly for a very, very fixed set of domain of problems where you have sufficient enough data and also the environment or things are not changing. For example, if you are a person, face recognition, probably your face will look the same or about the same, maybe will have certain features at least in 5 years, in 10 years. Or if you are voice recognition, you have certain features in in your voice. But for example, in the financial market, everything is changing. Pre-crisis, pre-2008 crisis and post-crisis, everything is different. And also regulatory change and a lot of things. Sometimes you don't have enough data. So for some problems, the old traditional method, is even more efficient than deep learning. And also deep learning is very, very computational, power intensive. So if you view it as a tool to help some non-domain expert try to get into the field, it can be very attractive. But if you want to be in an industry where winner takes all, sometimes still the dominant methods are still like a domain expertise plus like a feature extraction, like or like more algorithms as like mentioned as with more explanatory power.
Okay, I'm gonna give a short answer. So my experience is sometimes I talk with because I'm a lab guy, so I used to like this fancy deep learning algorithm, but sometimes I talk with my BU people, they said, okay, it's just overkill, so it's 杀鸡用牛刀 in Chinese sometimes. And like for example, there was, I remember there was one use case that they want to use, because we run a lot of servers, they want to identify the next failure, by collecting a lot of events in the server. So I came up with deep learning neural networks and talked with the PU guy, and they run that, and they compare the results with their algorithm that has already been there for years, which is the random decision tree. They said, okay, we see a little bit accuracy improve, however, the cost of running a deep learning algorithm is significant more. So they don't prefer to use deep learning in that use cases. And of course, they also mentioned that sometimes you don't actually have enough data. So that means the deep learning that you have really big engine, but you don't have enough field. So you cannot really power your sports car in that way. Thanks.
Okay, good, thank you. So I have a question for the audience. Right now, so far we asked a question for panelists. So I have a question for all the audience. So how many of you have your own startup on AI area? We do have a few. Okay, good. So I think the rest of you probably also think, okay, AI is a hot area, but what would be the next opportunity in AI if you want to have a startup company, right? And for me, it's the same thing. As a professor, if I want to do some startup, what would be the new opportunity? So I do want to ask the panelists a question, which is the number 4 question over there. What are the new market? What are the new market opportunity for AI if we want to have a startup company? Okay, so for the co-founders, for the startup founders, and also for our IBM VP, can you give us some suggestion if we, as audience sitting there, don't have a company and we wanted to have a new startup company, what are the new opportunity out there? Okay.
I was hoping to go last, but yeah, sure. So I think the answer, frankly, it's a very non-glamorous, non-sexy answer, believe it or not, right? In the startup world, you want to think about the flashiest, shiny new thing that you can, think of, and you think that's going to change the world. Again, grounding myself in my roots of enterprise software, large enterprise businesses that are, 100 billion plus, and what have you. And I think Chris's company, the problems that you're solving are more in line with sort of really groundbreaking problems that have to be solved. Let me give you something as mundane and simple. Take your CRM processes, take your ERP processes, take your HR processes, take your Workday processes. The amount of decision making that is happening that's manual, although there is all the information, the data, and the context associated with that, to automate those decisions, to make more intelligent decisions, the opportunity there is huge. So, although it's not a very exciting answer, I'm going to say it's grounded in the reality of today's, how deep is the penetration of quote-unquote AI within the enterprise? I would say go to your systems of record. Go to your CRM, go to your ERP, go to your HR systems. Understand the processes and the workflows. Look at the data and the context that you have with each decision-making point in that process. See where you can inject intelligence with your AI technologies and techniques, and you're on your path to billions of dollars. So maybe not a very exciting answer, but that I really believe is.
Thank you. And then for the next 3 CEO of the startup company, you are doing a startup right now. So if you want to give advice to others, like what other opportunity you should go, what would you suggest? What's your suggestion? Okay.
Yeah, sure. I think you think about founding a startup based on an understanding of what AI can do in the world. And the best way to think about AI is AI lowers the cost of thinking. right? So a lot of thinking in the world is high cost, right? And there are very few people who can do certain kinds of it, right? You know, they may be people inspecting chickens for their gender, right? They may be people inspecting products for their quality, right? These are visual recognition tasks. The humans who can perform them sometimes are very rare. AI can do it easily, right? And you can replicate that software infinitely. So like, there's probably an enormous opportunity for sort of the measures the quality of green beans coming off of the processing, right? And so on and so forth, across every product in the world, letting companies know whether or not what they're pushing out into the market is flawed or not, right? And then taking it a step further and trying to figure out which factors led to those flaws. Right? That's an easy one. So come to AI with some of the processes you know. Ask yourselves, where is pattern recognition necessary, right? Whether it's for text or images or sound, and then you can probably then there's probably a neural net model or an algorithm somewhere, right, that can do that work very easily. That's what I say.
So I guess many of you from different backgrounds have your own business, your own vertical you understand. So I think that's great to start with. And I think it's always great to add AI or some sort of technology that can help you improve efficiency in it. So a few preconditions. One is first you need to make sure you can have the data if you want to use like a stuff like deep learning, those type of things. Make sure you have the data and you have the basically the talent and the computing power to do it. The last one should be relatively easy. Data is mostly the most difficult part normally, especially for example, such as the medical domain, it's very hard to get it. So this is one way. The other way is like my characteristic way we focus on problems that you don't really have that much data, and you need that much data, and then you can sort of control the environment in relatively manageable scenarios, and you can achieve success without that much data because of our own technology. So I think it depends on the status of the company and type of the company.
For the audience, if you are not haven't studied an AI company, it means like you are not an AI researcher. So from this perspective, my advice would be, do not focus on any infrastructure or like any AI research algorithm or hardware, like those are getting commoditized. But those opportunities will be taken by by companies like Chris or like someone who has a PhD in those fields. But instead, the future of AI is focusing on the vertical areas. Think about like what your domain knowledge is, and also think about where the most impact will be. For example, for big industries like finance, healthcare, education, those are all very big industries. And also, if you think about Uber disrupted, the taxi industry is also very big, and also focusing on the ones with the most number of people employed, and also the lowest efficiency that can be replaced by whose efficiency can be increased by artificial intelligence. I think those are there are still many opportunities beyond like basic research or academic research or like infrastructure research. And those will, I think the opportunity will last for another 5 to 10 years from the infrastructure going into many detailed vertical areas.
I think that we are running out of time. I would like to give our audience a last chance. But you are very quick.
So we talk a lot about the benefits we can get from the AI technology. As a user or with the AI technology, maybe every day we are using the AI technology, like we're using the Google search. We buy the air ticket from the air ticket agent, and we buy something recommended by the government. So as a user, the more I use the technology, I feel more convenient with those results. But one concern is I lose my privacy with those technology. So as you are the technology expert, so every day I think you are also using those technology. How can you protect your own privacy? Or is there any good way you suggest us to protect our privacy? That's my question.
There's a lot of interesting work going on around encryption and training neural nets on encrypted data, right? So that the decisions they reach about a certain individual's behavior happen without them knowing who it is, right? So that you can create a barrier between these nets that know everything, right, and the users who know their own identity, right? So Apple's said a lot about differential privacy. You may have heard about. There's some other research going on with I think it's called CryptNet, coming out of Microsoft research. I would recommend you look into that. But one of the the people on stage have mentioned many of the kind of cutting edges of AI. It's about the efficiency of the computations, right? It's about how much data we need to expose it to, and it's also about how well it works with encrypted data. Because as soon as you can work well with encrypted data, you come up with smart decisions to give to companies where you're still protecting the privacy. Does that make sense?
Well, just to add a non-technology-based answer to that, we've thought about this a lot, again, from a large company perspective. I think ultimately it comes down to the value. Think of your user experience. So the more the value of the AI-powered solution, whatever the solution is, the more the user is willing to give up their privacy. I mean, it's only because of the seamless Uber experience are you willing to give in whatever data you give in. So if there's not the value of whatever the experience is that's delivered to you, if it's not, if that doesn't warrant your giving up your, the privacy to it, I think you're giving it. This is kind of more of a business value response and not really a technology response to that.
I think privacy, it is a technical problem. It is more of a people problem. There are many institutes like, for example, OpenAI. They are actually working on such kind of regulations. So, I mean, it's just getting started, but I think it is a problem that is not unnoticed. So people are really focusing on that, and they will come up with proper solutions.
Good question. Actually, we did see some use cases that the users facing the privacy issues. So what we worked on in the labs is something we call like training on the edge devices. So basically that we're not only doing inference on the edge, we have some embedded some powerful devices, hardwares on the edge devices, try to do the training on the unlabeled data when the data is constrained. For example, the traditional models, you have to like transfer the data back to the cloud. You do the use GPU to do the training. However, we thought about doing training on the edge devices if you have some powerful, for example, the integrated GPU, FPGA, and some other form of hardware. So we did look at these issues and try to think of solutions from the hardware perspective.
Okay, I think that we are 40 minutes behind the schedule, so let's wrap up the panel and thank all the panelists. I do have an announcement. Our next door right now will start.